Hi guys, today we are going to start our quadratic function unit. We are going to talk about graphing quadratic functions. We'll toss in writing equations of quadratic functions, and then no unit will be complete without a word problem. To minimize the length of each video though, we're going to spread it about 6 short videos or short-ish, and then that's it. Okay, cool. All right, so we had talked about functions in the beginning of the semester. We are going to focus exclusively on quadratic functions. So there are different ways to write the equation of a quadratic function. One of them is standard form. Okay, so a quadratic function is said to be in standard form if it looks like this. So f of x equals ax squared plus bx plus c. So a is the leading coefficient, b is the coefficient of the middle term or a linear term, and c is the constant term. So this is a degree 2 of a polynomial function, so the graph should be a parabola. You know, some of them open up, some of them open down. So this will be like the graph of the square function. Okay, the graph of y equals x squared. Now it's always nice to have a sense of how this parabola is going to look like before we even lift a pencil. Before we do that, let's go ahead and talk about vertex and axis of symmetry. So vertex, depending if the parabola opens up or down, that will take a slightly different meaning. If the parabola opens up, then the vertex will be the lowest point on the curve. If the parabola opens down, then the vertex will be the highest point on this curve. Cool. Awesome. So axis of symmetry, what is that? The axis of symmetry is the vertical line that goes through the vertex. So we identify the vertex and then we do a vertical line through it. Now, what is so special about the axis of symmetry? The special thing is that if I were to like take one side and fold it about the other side along the axis of symmetry, I should get the other side. Okay, maybe I should have said it a little bit better. Okay, so let me go ahead bust out my special effect. You know, we have low-tech special effect, and then we're gonna go ahead grab the axis of symmetry. So we locate the vertex, which is the lowest point on this curve. The axis of symmetry will be the vertical line that goes through the vertex. Okay, and then how am I going to fold this paper? You got it with my other special effect. Okay, so if I were to take one side and fold it about the axis, as you can see, I should get the same side over here. So like the ends would meet. Okay, so pretty much it's like it's kind of like when we, I guess if I use the modern words, if I take a selfie and when I look at the picture, I should look exactly the same. Yeah, maybe I should have skipped this part, but I'm not gonna start this video again. Okay, cool. So let's do this. So so from the top, we had said that there's different ways to write quadratic functions. One way is standard form. Another one, if I'm asked to graph, is my favorite form, vertex form. So a quadratic function is said to be a standard form if it looks like this. So f of x equals a times the square of x minus h plus k. The reason why this is one of my favorite ways to write a quadratic function when asked to graph is that it allows me to see the vertex right away. So the vertex, we have no time to write the word vertex. We will abbreviate it by uppercase V. The vertex is given by the ordered paired HK. So the question is, how do we identify the value of H? The value of H is a number that follows a subtraction sign, you know, after the X. So X minus H. So if we have X minus a number, that will be the value of H. What if we don't have X minus a number? Then you force a subtraction. What is K? K is just whatever that constant term is. Okay, so let's go ahead and illustrate this with our first and only fun problem. So it says a fun problem, yeah, because math is fun. Okay, graph the quadratic function. Please locate at least 5 points on the graph. Identify the vertex and axis of symmetry. State the domain and range. Okay. Now, depending on how much you remember from the previous unit, you can graph this by using transformations of the graph. So we will say from the graph of the square function, what is this? Shift 1 left, reflect about the x-axis, and then we drop 2, okay, or shift 2 down. And you can totally do that, but since we already did it in this format in our earlier unit, I want to give you an alternative way. So when you take your assessment, quiz or test, you pick and choose. So first of all, I'm like, okay, let me go ahead and identify the vertex. Okay, so the vertex is given by HK. And I want to know, is this really in vertex form? I forget what that looks like, so let me just go ahead and write down the general vertex form. So we have f of x equals a times the square of x minus h plus k. Okay, so let's go ahead and identify our vertex. Okay, let's take a pause right here. Okay, so hopefully that lighting is a little bit better. I like to keep it nice and bright, but I think it was too bright, so we'll go with the romantic setting. Cool. All right, so let's go ahead and identify the vertex. So let's identify h and k. So h is the number that follows the subtraction sign in the binomial. In this case, we don't have x minus a number, but it's okay. We're gonna force it. We're gonna write it as negative x. We're going to change the operation to minus, so we'll change that positive 1 to negative 1. Okay, so we're going to force a subtraction problem. Let me go ahead and insert my parentheses just so I have a little visual separation. So now we have x minus a number. Cool. All right, and then we'll bring down the rest of the problem. Oh, that's not plus. Sorry, put that in the blooper. We have minus 2. Okay, this is why I need to put my fingers on here. So with that being said, let's identify h and k. Okay, so h is the number that follows the subtraction sign. The number that follows the subtraction sign is negative 1, so the value of h is negative 1. K is just that loose constant term, so that loose constant term is negative 2, so we have k equals negative 2. So let's go ahead and talk to ourselves. So we're going to tell the world the vertex is given by hk, or negative 1, negative 2. Something that I want to point out is this, although we don't have to identify if the parabola is going to open up or down, it would be nice if we had a sense, just so we can check our number sense. So in this case, we are going to focus on the value of a, something that I failed to highlight before. So when we look at the leading coefficient, or the value of a, we should have a really good idea if the parabola is going to open up or down. So it says if a is positive, then the parabola should open up, but if a is negative, then the parabola opens down. Yeah, memorize that. Okay, or you can just vent out your feelings. So if a is positive, you know how I'm gonna feel. Happy. And what do we do when we're happy? We smile. Okay, so that's code for if a is positive, or the leading coefficient is positive, we're opening up. If a is negative, how are we gonna feel? Yeah, you guessed it, sad. So the saying, turn that frown upside down, that's not happening here. Okay, cool. So if the leading coefficient is positive, or if a is positive, we're smiling, so parabola's opening up. If the leading coefficient is negative, a is negative, we're sad, so parabola is opening down. Cool. All right, so coming to our problem, let's go ahead and identify the value of a. Because we have this function in vertex form, so a is whatever is in front of this binomial right here. Okay, so in this case, a is negative 1, so a is negative. That makes me sad. Okay, so when we do the math, we should have a parabola opening down. If not, then I really am gonna be sad. Okay, so let's go ahead, start by locating our vertex on the graph, which is negative 1, negative 2. Bear with me. Okay, so 1 to the left, and then where am I? 2 down. Cool. And then what I'm gonna do, I'm gonna go ahead but graph the axis of symmetry. Why? Because I like to, but also because I need to identify it. Okay, so the axis of symmetry is the vertical line that goes through the vertex. So let's go ahead and do our vertical line going through the vertex. So we're gonna make it dash because the axis of symmetry is not part of this function, but we're gonna use it as a marker. Yeah, that was fun, and apparently I can't do a very straight line because it's a little bit off. It's okay, no one's gonna know. What will be the equation of this vertical line? So this vertical line goes through -1, so we want to tell the world that x has to equal -1. So the only way that x equals -1 is if we write x equals -1. Okay. Cool. So how you choose to graph it thereafter, it's up to you. I mean, if you want to use your calculator, no one's gonna know. Oh, I lied, you have to show some work. What I'm gonna do, I'm gonna write down the vertex again. So we have that the vertex is -1, -2, and then we're just gonna do a regular XY table, or table of ordered pair solutions. The first x value that we're gonna pick is it's gonna be the x value from the vertex, which is -1. So when we substitute a -1 for x, when we do the math, that should give us -2. We're not going to do it again. I'm just going to put it there for organization. And then we can pick any other x value. You know that 0 is my favorite number. So when x is 0, you know, what is the value of this function? So where should I show my work? Or you can punch it in. You go ahead, write down the function. So the function, we have -square of x plus 1 minus 2, and when x is 0, I want to know what is the value of this function. Okay, we take our time. Sum of 0 and 1 is 1. Square of 1 is 1, and then that difference is -4. Okay, so let's go ahead, graph this bad boy with confidence. So we're at 0, -4, so we stay put, and then we go 4 down. Okay, so we are asked to locate at least 5 points on the graph. I'm not an overachiever, so if they say at least 5, I'm gonna go with 5. We have no time to do 6, 7, 8, or 9. Now, if you keep your cool, we can go ahead quickly graph another point without having to do more math. So in this case, we're gonna use the axis of symmetry to get to another point. So in this case, if this point is 1 unit away from the axis, when we reflect it, we should be 1 unit away on the other side. So we're one unit away. Let's go ahead, reflect. Or in modern words, if we were to take a selfie, we will be right here. So just like that, we have 3 points. The first one comes from the vertex, the second one came from the math, the third one came from the reflection about the axis of symmetry. So we need 5 more. Go ahead, pick any x value. I'm gonna pick 1 because I like 1. Okay. So when x is 1, go ahead, put it right here. Let's go ahead, find f of what. So that will leave us with a -square of x, or 1 plus 1 less 2. I'm not sure if you can see that. Cool. The sum of 1 in itself is 2. The square of 2 is 4. And the difference gives us -6. So let's go ahead, log it in our table of values. Okay, so we're at 1, -6. So we go 1 right and 6 down. So that gives us 4 points. Let's go ahead and reflect it about the axis so we can get our 5th and final point. Okay, let me go ahead, zoom in. Okay, perfect. So this point is 2 units away from the axis of symmetry. So when we reflect it, or you know, we bounce it, we mirror it, or selfie it, use your favorite word, whatever the cool kids say. Okay, so this point is 2 units away from the axis. So when we reflect it or bounce it off, we should be 2 units away. So right there. So we are asked to graph this by locating at least 5 points. So the first one came from the vertex, the second one came from our math, the third one came from the reflection, the fourth one came from more math, and the 5th one came from the reflection. So we are going to do our best to do a nice smooth curve, a nice smooth parabola opening down. Supposedly it should go through these 5 points, but due to human error, sometimes it doesn't look so nice. So we'll just try our best. Okay, no pressure, guys. I did it. I overshot it. Yeah, so I came into too steep. Yeah, it's okay. I tried my best. If I had a pencil, I would try to redeem myself. Every time I try to redeem myself by making it look pretty, I make it look worse. Okay, I'm not gonna sleep tonight, but it's okay. We need to keep going. Okay, so that will be the graph, and we have 5 points that were clearly highlighted, but now they're not. Okay, so aside from graphing, we were asked to identify a few things. One, the vertex. We already identified it, but the way this problem is phrased is like a fill in the blank. Okay, so we said that the vertex is given by -1, -2. Cool. Axis of symmetry, we said it's given by the equation x equals -1. The popular mistake is that students will just write up -1, but -1 is not an equation. That -1 does not translate to this vertical line, so you need to put x equals. Okay. The domain, you can get the domain either by looking at the function itself or by the graph. Okay. So the domain is going to be the set of all the input values or the x values. So if we do it from the graph, well, if we do it from the function itself, you know, what values of x can I use? In this case, we don't have a fraction or a radical, so we can use any real number, you know. But if we look at the graph, what are the x values that are used to create this graph? So in this case, looks like we have all the negative x values, and then we have all the positive x values. So in interval notation, it will be the interval from -infinity to +infinity. Let's go ahead and lock it in. Where does it say interval notation? There's too many numbers to spit out, so we put it in interval notation. Range, it's going to be the set of all the output values or the y's. In this case, we go from, for domain, we go from left to right. For range, we go bottom up. Okay, so the lowest function value is a lie, but we're coming from the negative side, so it's going to be from -infinity to whatever this is. Let me identify the ordered pair. So this was the vertex, which is sorry, that's just how I speak. So this is the vertex, which is -1, -2. So range, what are the y values? You know, what are those outputs? Lowest y to highest y. So the lowest y, we're coming from the negative side, so it's going to be from -infinity, and the highest y will be -2. So the range is given by the interval from -infinity to -2, where -2 is including. Cool. Alright, so that is the end of this supposed short video. Sometimes that just has to go down. Thanks guys, we got 5 more.